Instrument landing system. The purpose of the instrument landing system is to provide guidance in the horizontal and vertical planes to an aircraft on final approach. The guidance provided enables the pilot, regardless of weather, to fly the aircraft to a position from which a safe visual landing can be made. Many installations can also provide guidance for suitably equipped aeroplanes to make an automatic landing in conditions of zero visibility. Category 1 is a decision height of 200 feet with a runway visual range of 800 metres. Category 2, a decision height of 100 with an RVR of 400 metres. Category 3A, decision height 0 feet with an RVR of 200 metres. And Category 3B with a decision height of 0 feet with an RVR of 50 metres. The localiser for the ILS. Localiser transmissions are horizontally polarised and transmit in the VHF band. The frequency allocation is between 108 to 112 MHz at odd tenths. For example, 108.1 and 109.3. The even decimals are allocated to VOR facilities. To maximise the use of the allocated frequency band, many ILS installations work to the second decimal place at 0.05 MHz intervals, for example 108.15 and 109.35 MHz. Localiser coverage. The classification of emission of an ILS is A8W. The airborne installation compares the respective depths of modulation of the two lobes of 150 Hz and 90 Hz. And determines a difference in depth of modulation. The comparison is used to produce a voltage which energises the localiser pointer on the aircraft instrumentation, indicating whether you are left or right of centreline. The range of the localiser coverage is out to 25 nautical miles, 10 degrees either side of the centreline. Closer in, at 70 nautical miles, the coverage is 35 degrees either side of centreline. For the ILS glide path, the 150 lobe is represented by the colour blue. The 90 Hz lobe is represented by the colour yellow. Glide path coverage, in terms of range, is out to 10 nautical miles, 8 degrees either side of the centreline. In terms of elevation, it's 0.45 times the glide path angle, typically 3 degrees, or up to 1.75 multiplied by the glide path angle, typically 3 degrees. Marker beacons, 75 MHz. The airway marker inner marker is 75 MHz non-A, 2A type of emission. The frequency of the modulating signal is 3000 Hz. The white indicator lamp will flash. A high-pitched 3000 Hz tone is keyed to form dots at a rate of 6 per second. For the middle marker, the frequency of the modulating signal is 1300 Hz. The amber indicator light flashes. A medium-pitched 1300 Hz tone is keyed to form alternating dots and dashes at a rate of 2 per second. For the outer marker, the frequency of the modulating signal is 400 Hz. A blue indicator lamp flashes inside the cockpit, and a low-pitched 400 Hz tone is keyed to form dashes at a rate of 2 per second. ILS indications. The indications show that the airplane is below the glide path and to the left of the centreline. In terms of azimuth, 1 dot is worth 0.5 degrees, so a full-scale deflection of the needle is 2.5 degrees. For the glide path, 1 dot is worth 0.14 degrees, so a full-scale deflection is worth 0.7 degrees. Descent. How is rate of descent on the ILS calculated? There's a formula. Rate of descent in feet per minute is equal to glide slope angle multiplied by 100 multiplied by the ground speed divided by 60. How is the height on descent on the ILS calculated? Height in feet from touchdown is equal to glide slope angle multiplied by 100 multiplied by the distance in nautical miles. Descent example. An aircraft is flying at 280 knots and needs to descend from flight level 80 to flight level 10 at 700 feet per minute and be at 17 nautical miles from a VOR when at flight level 10. At what distance should the aircraft start its descent? Well, flight level 80 is 8,000 feet and flight level 10 is 1,000 feet. So calculate the height to be lost, which is 7,000 feet. The TAS is 280 knots and the rate of descent is 700 feet per minute. Travelling at 280 knots in 10 minutes equates to 47 nautical miles plus the 17 nautical miles, which adds up to 64 nautical miles from the VOR.